There we go.
So,
HVAC system's a little noisy.
no worries, no worries. Um, welcome. Thank you for doing this, Thomas. Just to give you a little bit of an insight as to what I'm doing is I conduct online interviews with people that have held numerous positions across various industries, just to get a little bit of their insight, best practices, and just sort of like how they feel, et cetera, et cetera. I understand currently you're the VP at Stanford University, right?
Well, I'm the vice president of the local alumni association here. Um,
Okay, great. So you want to run us through your whole background?
sure. Very simply, I've done two aircraft engines, one lift fan, 11 nacelle projects. I've worked for CDI Aerospace, for Goodrich, which is now part of Raytheon Corporation, Jeppesen, which was part of Boeing and is now being sold off to Thoma Bravo. I've been in and around the aerospace industry for some 25 years, done lots of new product introduction, including the A320neo with Airbus.
That sounds epic. Aerospace was an industry I was always very interested in, but it was also an industry that, well, it didn't exist in Greece because I'm based in Greece. And it was very tough to get into in the rest of Europe. So let me ask my first question then. In terms of structural challenges, what do you think are some challenges the aerospace industry faces?
I've picked out four to talk about briefly, and the first is supply chain abuse. If you haven't been following the news, or if you're in Greece, so some people may not be aware that Boeing is buying Spirit AeroSystems, which is their super tier one supplier for the 737 MAX, 767 inlets, fan cowls, and also the 787 Section 41, the front section of the fuselage. Uh, this is a
Okay.
huge transaction. It was spun off back in 2005, I think. I actually worked there after they were spun off. But the real underlying reason is that there's been so much supply chain abuse that Spirit is losing money hand over foot. And it's not just Spirit, it's the entire supply chain. Boeing especially went after their suppliers very, very hard, trying to reduce their profitability. And they had year
Hmm.
over year cost reductions. So think about this. To quote Stephen Sondheim, it's two parallel lines that meet. You have year over year cost reductions on one side. On the
Hmm.
other side, you have everyone would like a raise, right? Inflation. You have raw material cost increase. Somewhere this has got to give, right? You just can't keep reducing prices year over year when fundamental materials costs are going up, energy cost is going up, wages are going up. So this has just not impacted Spirit. It's impacted all these small machine shops downstream. The tier ones get the news, like, what used to be Goodrich, the Spirit, Vote, and a few other tier ones. But all these are backed by these machine shops, many of which are $20 million or less in top line, margins of around 6%. If they mess up a big part and they have to scrap it, they may have lost their profitability for a month. So the
Wow.
um, yeah, yeah, there are people making little bitty parts, but there are people making big parts like ribs and the door hinges for a cargo door. That's a big part. Um, so yeah, it's pretty interesting to take a look at it from the perspective of what's happening in the supply chain. Um,
That's
so
insane. Do you think,
essentially,
sorry, do you think it has anything to do at all with what we've been hearing about Boeing the past few years and the issues they've been facing in terms of technical equipment on their um airplanes?
I think that's a slightly separate issue.
Okay.
Some of the quality concerns of the manufactured parts, like the door that came off of I think it was Alaska Airlines,
Hmm.
um, that's a quality issue. That's a manufacturing quality issue. I think the next one that you brought up is actually the next one on my list, and that's workforce interest.
Okay.
Uh,
Go on.
both white collar employees and blue collar employees are no longer that interested in working for these big aerospace companies. When I graduated, university first degree in 1994, aerospace owned technology. If you were doing high performance computing, like I was back then, I mean, aerospace was the place it was used. There was no one else using, numerically intensive computing. But now, if you're a smart kid in college, you're going to go work for a FANG company. They'll pay better. They'll give you coffee, then they have the better technology in many areas.
Wow,
And
okay,
then
that's
the
very interesting.
and then the blue collar is even worse. I mean, yeah, I don't know if you've ever been around an aerospace factory. They tend to start pretty early in the morning, like
Sure.
7:30 in the morning. You're allowed to be 15 minutes late twice within, I think Spirit was 30 days. It's been a while, but it's a relatively short time, or else you were fired.
Oh, wow.
And yeah, it's an assembly line. It's not quite the same as like a Ford assembly line, but is an assembly line. But it has that very tight union mentality. And if you just decide, I'm a Gen Z, I'm a millennial, I'm just not feeling it this morning. I'll just call in and say I'm not coming in. That doesn't work. And the work
Old
is
school.
hard. I mean, I don't know if you've ever picked up a rivet gun. They weigh on the light end about 5 pounds, and you're going to
No, sure.
reach through a hole and you're going to bend your arm and come down. Now, there's been a lot of work done on ergonomics to make this better. But these guys that are making, base salary 60,000, getting 20K in overtime, when they leave in their late 50s, early 60s, they're worn out.
Mm,
Their lifespan's not that long. So it's a tough work. Some of the chemicals are dangerous. Um, People just don't want to get up at 6 o'clock in the morning to go put bolts on an airplane. And it gets funny. Years ago, I was cross training in roller derby. I'm a cyclist. I'm a road cyclist. Anyone that Googles me
nice.
will find this out. So I was cross training in the winter in Wichita, talking to this nice young lady who lost her job at Taco Bell. And I'm like, well, Spirit, we'll hire you. All you got to do is pass a drug test. We'll train you. No one knows how to run a rivet gun from high school. That's not a class. She comes back next week and says, I just don't want to give up my weed habit. So I'm like, hold it. This is some years ago. You lost your $7 an hour job, minimum wage job at Taco Bell. This job will pay starting 3 times what you're getting paid at Taco Bell. And all you got
Mm.
to do is not use weed for a month. And you don't want to do it.
Well,
Uh,
look, I'm not defending her, because
she's a great person. I liked her.
I've been always on the ambitious side of things. But ambition is not for everyone. Some people are just not willing to go that far, not meant to cut out. And there's two sides to that coin. I mean, there's some very good arguments for the Gen Z generation behaving the way they behave, and there's some very, very good arguments against it. I would have personally cut out the weed and focused on doing it, but I mean, I get it. That's all I'm saying. I get it.
I get it too. I mean, I know people that are Insta famous when you can make, you know, a young lady that was an exchange student from, I think she was from Italy, lived with a friend of mine. He was French, and as an exchange student, he had
Hmm.
high school students as well. She had 250,000 followers on Instagram. She could care less about what happened in the school.
Yeah,
She was like 17
obviously.
years old. No, she was like 14 years old. She was 14, 15 years old with 250,000 followers. And that's enough to get some money. I mean, she was buying her own clothes.
I mean,
So
yeah,
I get it.
there you have it. And then what happens if in 10 years' time her following is not there, or she becomes non-famous? So then she'll have to get a normal job like a normal person, and how is she going to be able to adapt to that?
Eh, You know, uh, this is not a new problem. There have always been people that have made money for short periods of time based on their appearance. Comic-Con. I went to my first Comic-Con this past weekend. I got invited by a
Okay.
friend. And I'm meeting these stars that I met the James Madsen.
Hmm.
I think I got the name right. He played Spike on Buffy, the
Okay.
Vampire Slayer, which is a pretty
Hmm.
famous TV show. Had like a job for
Hmm.
10 years. Now he goes around Comic Cons and he gets paid to speak and signs autographs for $50 a pop. I mean, it's sort of the same thing. So this is not new. But a lot of these people will not be able to go to Comic Con. So
Sure.
anyway, the point of it was is workforce interest. Um,
Hmm.
the next component of what's really going on is product complexity. It's a structural challenge. If you look at the 737 MAX, the MCAS group was a group that never had any issues before. You look where the problems have occurred before. Hot gas path areas, specific software areas, fan cowl latches, wherever the problems are before, that's where you look for problems in a new program.
Hmm.
This is a group that didn't have a problem. I was not read into this, so I'm just gonna postulate here
Go for
that
it.
the person that was in charge and had led this for probably 20 years, retired, and then other people carried this on and they thought they knew what they were doing, but no one really noticed the guy that had been running this had retired, and then there was a hole created. This happens now. Um, aerospace products are really complicated and they're really built around product safety. So I think that's a real challenge in structural challenge because how do you keep this knowledge? I'll give you a really simple one. If you look at the thermal anti-ice exhaust, there's a hole in the inlet. It's clocked over 5 degrees. Why? I mean, you can copy this. You can see that every inlet looks like this, and so you can copy it. But does anyone know why anymore? I don't know. I'm not going to say why here because it's someone's IP.
Doubtful.
But yeah, and I guess the last one I want to bring up, and this is going to be a weird one, but I will call it a lack of game-changing improvements.
Okay.
Airplanes are mature. They really are. If you go look at the Boeing Eco Demonstrator that flies around every couple of years, I think they've taken a year or two off because it's expensive. So you're going to give the cabin crew an active beverage count, so they know if you ask for a Coca-Cola that they've got it, or you ask for Bloody Mary that they don't have the mix that time. Um, Sensors on seat belts. That's cool. That way they can, go tap you on the shoulder, sir. You really haven't fastened your safety belt when we told you to. I mean, this is not a bad thing, right? But it's not game changing. Stay dry bathroom floor. For those of us that fly international a lot, it's kind of nice. But again, from an airplane perspective, it's not game changing. Um, what's game changing in the world of aviation? It's fuel economy. And that's driven by mainly what GE and Pratt Whitney can do. There's some improvements in external aero, the weight improvement, carbon fiber. A thing to keep in mind is 1 pound force of drag trades to about 30 pounds of weight. It's not quite 32.2. There's a formula. Turns out to be about 30. So if you can reduce drag, it's actually better than reducing weight.
Let me ask you something, right? So there's no innovation basically. That's what I'm hearing. But then back in the day, you had things like the Concorde, for example. So don't you think there's actually space for innovation in terms of speed and efficiency and things like luxury into it, generally optimizing it for a much better, faster, and safer travel?
So those are not mutually inclusive events. So
Okay.
you can certainly optimize for safer travel, and that's essentially what we've done. We have not optimized for faster travel because faster
Why not?
travel consumes more fuel per mile. So your fuel economy is going to go down. Your
Mm,
drag is going to go up. Your cabins are going to get smaller and noisier. Not that many people have been in a Concorde cabin. It was a 2x2 and it was noisy.
okay.
The faster that you go, the more turbulent boundary layer noise you have along the aircraft, which is synonymous with drag as well. To give you a perspective, the 787 has enough dampening, noise dampening, just for passenger comfort as a Volkswagen Beetle. That's a
Oh,
lot
wow.
of just to make your ears comfortable. I mean, they could have given you all like a Bose headset, right? But we don't do that. When
Hmm.
you walk on the airplane, you don't get a Bose headset, which would be a heck of a lot lighter than all this acoustic treatment. So you
So
have
why
to
don't
think
they do
about,
that? Why don't they give you a Bose head?
yeah, and take out the acoustic treatment. Let's hope O'Reilly, I think it's O'Reilly, O'Brien at Ryanair doesn't see this because he will try it. I mean, I've not met the fellow. I've, seen his interviews. I appreciate what he's doing for moving people around Europe at the height of cost efficiency. I mean, brilliant. Make people pay to use the restroom. Why? Bodily fluids are heavy. And if you can take, 20, 30 pounds off your airplane, that's fuel, right?
Hmm.
I mean, it's weird to read it, but it was a smart move, and saves it saved his airline money.
I don't know.
I will say,
I have mixed feelings about Ryanair. I cannot say something positive. I'm sorry.
I mean, I've flown Ryanair only a couple of times, and there was a Ryanair pilot deadheading, to catch his plane, and they made him pay for the water bottle. And he was sitting beside me. That was funny. I
I'm
mean,
sorry.
but
You
it's
were saying I
Ryanair.
interrupted. Yeah,
You know
yeah,
what
it
you're getting.
is.
So what I'll make is there's a lack of game-changing improvements in the current design space. We want to travel around Mach point 0.7 to Mach point 0.8 between locations. If you want to go,
Hmm.
I know Alexei at Nautilus. I'm amazed at how he's promoting his aircraft. And I was looking at it some years ago for some friends of mine with the former Afghanistan government as a way for them to move cargo around Afghanistan because land transport's extremely dangerous. Not just from the Taliban, but also just the road infrastructure there is horrible. But if you're going to do something like a blended wing body, that has a lot of surface area, a lot of external drag. You're now talking about flying at maybe 250 miles an hour instead of 600 miles an hour. Drastically changes the equation of what you're going to do. For cargo, this is great, but are people going to be satisfied flat, having, four times the time, three times the time in the air to go between two locations? Certainly, if we slow down, we get more fuel economy, and people care a lot about fuel economy right now.
Hmm.
But if you want to get there faster, it's going to cost you more in fuel. And that's just math.
What about combining it with alternative sources or maybe a hydrogen-powered plane or something of that sort? As dangerous as that might sound.
There are some really cool concepts out there. I have friends working on hybrid electric aircraft. I have to be careful not to name anyone here. If I actually name someone, just kind of, edit out that second or two. Um, there are great ideas. The level of maturity is pretty low,
Hmm.
and challenge in commercial aviation is that you're flying grandmas and grandkids. The level of safety is here. If you look, and this is kind of a separate section I'd put in, but if you look at where real innovation is happening, it's in space flight. Why? You're taking up satellites, which don't have any relatives,
Mm.
um, or you're taking up people who have been willing to sign up to the high risk. I think it's cool that William Shatner went up there. I think the four ladies that went up, I think it was space. I think it was
No,
it
no, it was
Virgin?
Virgin. It was Virgin. It was
Virgin.
Bezos.
I think that is really cool. I mean, other people, if you're, should they pick those four? I don't know. Don't have an opinion, but it's very, very cool. But they signed on the dotted line with full realization of the risk. When you're talking about commercially transporting people, that risk factor has got to be so low. I mean, it's often quoted, it's safer to fly than to drive, and it truly is. Um, but you have to think about where what industries can tolerate the risk that comes along with innovation. There is no shoulder at 35,000 feet. You can create an innovative car.
Yeah.
It has a problem. You pull over on the side of the road. Maybe it's a mountain road, it's not a great location, but you can pull over. There is no pull over at flight level 350.
Well, if you put it into that perspective, it does kind of make sense. I was just expecting it to be, as an industry to have evolved into things like flight between Europe and the US within 1 or 2 hours, super fast, super efficient, super cheap. So as a
Well,
citizen, that's kind of what I
if
expected.
you if you want to fly between the US and Europe in an hour, you can go buy a space shuttle, get one of those, and launch yourself over there, and you can do it. except it negates the last two things you said. It's certainly not going to be cheap. If you want to get to Europe cheaper than, say, Iceland Air, you go slower. You get better fuel economy. I mean, in the United States, we had the Drive 55, during the fuel crisis in the 70s. And I grew up with, 55-mile-an-hour speed limits. And the reason was it saved fuel.
So I'm
So
sorry,
can you sell?
there was a flight last year that had like a special between Greece and New York for like 97 or 197 euros, something like dirt cheap. So what you're telling me is if I took that flight, I would have landed there a lot later than what Delta, for example, or American Airlines would have landed
I do not
flying
know
from
the
here.
business model put together. I can guarantee you that that airplane, whatever airplane they're operating, was operating in its normal capacity, whether it was a 737, A320, A330. But for whatever reason, they thought this was a good idea. Um, I do not understand how they made money on it, but maybe they made money as a publicity stunt. But we'd have to deep dive that one, know the airline, know their reason for doing it. Because, there are economic reasons to do things and there are public relations reasons to do
Mm,
things. This feels more public relations to me.
got it. Got it. I'm sorry, I sidetracked. Please continue.
Oh. So that was it. I mean, you can look at like some game-changing improvements are additive manufactured combustor nozzles for the GE LEAP engines. Incredible. Stage one nozzles, stage one turbine blade, cooling that can take those incredible temperatures. That's how the LEAP engines got their 15% performance improvement.
Mm,
Um, You can look at the Pratt& and Whitney geared turbofan, decoupling the fan speed from the engine core speed, allowing the core to go faster. Again, that's a tremendous and expensive innovation. So I'm not saying these things haven't happened, but these are incremental. We all know the math. Anyone who's taken a junior level propulsion class can tell you the math behind these decisions. They're not game changing. They're incremental. And where do you get the next, 14%? It's getting harder and harder because these were billion-dollar investments.
Let me ask you something. Now that you mentioned decisions, do you think culture affects these decisions? So you've done some Middle East, some Asia, some AMR, obviously. Do you think there are geopolitical dynamics that affect decision making in the aerospace industry?
There are. They're really complicated geopolitical dynamics.
Go on.
So, the first one is you sell to your allies. It sounds really simple. Um, Except you may have noticed that in the last Iran conflict, Israel bombed some F-16s.
Hmm.
That's a US built airplane, right?
Yes, sir.
So, ally has an awfully long time frame, right? Right. So
Well,
so
it's a
you you
matter of
you
perspective, isn't it?
well, but what I'm saying is in the aerospace industry, a key factor is if you're going to sell someone, I tend to work commercial, so let's focus a little bit more on commercial. You're going to sell
Hmm.
someone a commercial airplane. They want to be able to know that they can operate that airplane, as a direct buyer for like 20, 25 years. If there's a geopolitical fallout between the United States and that country, the US puts them on an embargoed list, all of a sudden they can't get airplane parts. So that airplane is just sitting there. And Russia's faced this, right? Russia has
Hmm.
bought some US airplanes. They can't get parts right now due to the embargo. They're trying to reverse engineer them with limited success. It's a very complicated geopolitical game. Um, there are some simple ones. Some simple ones are things like local content regulations, putting a design center in Turkey to spend some money in Turkey so Turkey buys your airplanes. That's really straightforward. Um, but the big questions are, how do I structure these deals, especially as someone who does not make the airplane, so that I can have a reasonable assurance that I'm going to get the product life that I expected. And this is not an easy question. Europe is safe. Europe and the US having a falling out. Not that likely. But let's say you're Burma, an
Mm,
interesting country, or Bangladesh. I mean, depending upon geopolitics, you guys can move quite a bit. And if you're Bangladesh, do you buy, some Airbus, some Boeing, and then do you take the risk of picking up some Comac just because, hey, if I run afoul of the US and EU, at least, I've got the Comac airplanes and China just wants my money.
oh, that's a tricky one.
We're in a very long cycle of business in aviation.
Mm.
My best friend from Stanford became a Catholic priest. And the story will make sense here in a second. Um, and he was talking about selling some property. And I'm like, my God, why did you do that? Your look ahead is 500 plus years. So you buy it, you own a piece of property, it's worthless, it becomes an interesting part of town, people construct, then it declines, but your look ahead is so far that you can handle that. As opposed to something like fashion, fashion
Mm.
and cell phones. A 3-year-old cell phone, I mean, it's practically worthless. It's what you give your grandmother so she has something to dial 911. Airplanes have a much longer lifespan. There are B-52s built in, I think, 1957, 58 that are planned into service into 2050. There's a 100-year lifespan on that airplane. Most commercial is more like
Holy crap.
60-ish. So
That's a
you go,
big, that's a big lifespan indeed.
it is. So from a major commercial airplane like a 737, you should expect around 20 years at a tier one operator, 20, 25 years at a tier one operator, being like a Delta, United, Lufthansa, British Airways. Then it's going to go to a second tier operator, maybe an Orion or an Allegiant. Orion actually buys some pretty new airplanes. So maybe an Allegiant. Maybe it goes to second tier countries. Then it goes to third tier. So you can easily have a 60-year lifespan of that airplane. And from a manufacturer perspective, you can make more. I won't say you will. You can make more money on the maintenance, repair, and overhaul of that airplane's life than you can selling the initial airplane.
Is it just as safe as a brand new one, though?
It can be.
But if you're going into a tier three country, will it be?
That's a question for that individual's country and their investment into aviation safety. It certainly can be. You can put it through A, B, and C checks. You can keep up the hardware. You can do everything you're supposed to do, and I would have a lot of confidence flying that airplane. If the airplane operator, which might be a private company, it might be a nation state, or an NGO is effectively operates a nation state, if they choose not to maintain the aircraft because of lack of money, lack of knowledge, you know, for whatever politics that play, yeah, it might not be as safe. But that has nothing to do with the airplane itself. It has all to do with the maintainability.
On that point, can I just jump back a little bit to the reverse engineering part? Um, it sounds to me like it would be cheaper for some tier three country to try and reverse engineer parts of a plane to fix it themselves. You said that it's not very successful so far with mostly Russia that has tried it, but why do you think reverse engineering can't work?
So the challenge with reverse engineering is, yes, you can go get a part off an airplane and you can put it on a CMM machine and measure it, give it to a drafter. They can clean it up and take it to a CNC manufacturer and you can make the part. If it's a standard aluminum part, yeah, that's reasonably successful because you've measured it. But the key parts of the airplanes are not aluminum brackets. They're parts inside the engine that have to withstand extremely high temperatures. Those are made by very few suppliers within the United States using metal alloys that you simply cannot reverse engineer. You can get a hold of it, and you can test it. You can pull it, you can melt it, but that doesn't tell you how to make it. The analogy is sort of like the Roman concrete. We can see Roman concrete all over Rome or all over Italy, right? And it was able to sort of self-heal. It had this great resistance to salt water. I've heard over the last few years, we think we figured out how they made it. So if you're looking at a stage one turbine blade off of a LEAP engine and you're China or Russia, you can buy, if you get a hold of the airplane, you can tear the darn thing apart and you can make that blade. You can make it out of aluminum, you can make it out of stainless steel, make it out of Inconel, but you can put it in there, it's going to melt. So the
Wow, that's
question
very
is,
interesting.
it's not can you measure and make a part? It's can you in most cases, it's can you make a part that can withstand the temperatures and the environment in that engine? And that requires special metals. And these are not metals that you can just go down the street to your local metal supplier and pick up. They're export controlled. Um, and of course, there's espionage, people trying to figure out how to make them all the time. Um, but even for the US, I won't name the supplier, but years ago when I worked on the Joint Strike Fighter, the turbine blades were made by a US supplier, and their failure rate was around 30%.
Okay.
So even the people that no, sorry, I got that wrong. Their pass rate was around 30%. So two out of every three turbine blades they made failed their first article inspection or failed their
So,
inspection.
so you had to hit the correct combination of alloys and metals, and it also had to be able to withstand whatever it is it had to withstand.
Yeah, it's complexity. I mean, there's things you can see. You can make a part that looks like another part, but can you make a part that performs like another part? This doesn't even get into things that are like software and other aspects that are hard to figure out. Um, it's the,
Wow.
but the metals,
So,
that's what makes U.S. aircraft engines, our U.S. Europe aircraft engines so desirable is the deep R&D that's been placed into being able to build these hot gas path components.
okay, okay, fair enough. Wow, that's interesting. Again, though, since we're talking about alloys, a combination of multiple elements, how does the US or, a big manufacturer get that correct each and every time? So, because it would sound to me like one 737 might have minute yet existing differences between itself and another 737.
So certainly there are differences between every 737. There's difference in length between the airplanes.
Okay.
There's something called conformance, and we're not going to go terribly deep into this because it's not my area of expertise. But if you want a fun case, look at the nut plate fiasco back in like 2009. They got a process inverted on making nut plates on the 737. So it's a massive recall of thousands of nut plates. It's complicated, but there are lots of checks throughout the system to make sure that conformance is maintained. So you get the part, it comes with a certification. That certification follows the part all the way from, the metal being made to the guy that CNC does the CNC machining. Let's say it's got to be ball peened, and that information continues to flow to the OEM and it's tracked. Yes, there are humans involved, but in general, there is a chain of documentation that goes along with the conformance to the certification and qualification of an airplane.
Okay, that's interesting. And is this different when it comes to defense, for example?
It's a little bit different for defense, but defense is not really my area. I guess the only thing I can say about uh, defense is there are a lot of complications with dual use technologies in defense. And
Mm,
that's sort of the extent of my knowledge. But think about it. There's a computer chip that's used in a military application that's the same computer chip used on a commercial application. Just it does its job. The questions are, what's the supply chain? Who made every component? How do we know that there wasn't something inserted into these chips that gives a foreign power the ability to do something
control.
malfeasance? So yeah, there's a lot more concern there for especially electronics, less so for metals, but especially for electronics and software.
Wouldn't you
Um,
have some form of checks and balance for the electronics and software, whether it's for commercial or defense?
you do, but there's the Space ISAC in Colorado Springs. That's one thing I consulted with them on supply chain a couple of years ago. It's a really complicated problem because for the commercial usage, you just want to know it's conforming, but you don't care about where everything came from. You just care it's conforming.
Hmm,
For military, you start to care about the depth of the supply chain where everything comes from. Especially in software, you know, you're going to run a Linux operating system and you can go get things on GitHub and you can use it, but people ask, well, how do you know this is safe? Where did it come from on GitHub? It gets pretty deep, and you quickly discover how little you really know.
I see. Huh, that's very interesting. I would have expected that well, both commercial and military would have their own operational software, their own systems, completely different from what we use on a day-to-day basis, and they would definitely not be sourcing from GitHub.
Well, if you're going to write software, if you don't want to do a matrix inversion, why would you write your own? You can just go download Householder from GitHub. I mean, um, so obviously there's processes, there are checks and approvals, but oftentimes you find out that MIT software license is out there, pretty standard for usage. Um, Log4j, right? Ubiquitous in software development for logging events. There was that Log4j crisis, and I think it was 2020. I was talking about the Log4j issue that happened some time ago, and that impacted commercial, military. It was all over the place
Okay.
because it was just a ubiquitous piece of software that no one really thought about.
Huh. That is mind-blowing piece of information right there. Okay, that's very interesting. Very interesting. And in terms of growing shifts towards regional aerospace ecosystems, especially in stuff like emerging markets, do you think dominance will basically stay between America, maybe Europe, or do you think that I don't know, the Sukhois or the S-400s might come up and take some space?
The For the next 10 years, the Airbus Boeing duopoly is relatively safe. Um, it's so complicated to build these airplanes, so expensive. You have to have, not just the airplane, the engine, even Comac is using the Leap C engine. Leap A is for Airbus, Leap B is for Boeing, Leap C is for Comac. They not comfortable building their own engine yet. If I look in the 10-year zone, the one that has the most question about is Embraer. So
Why is that?
Embraer currently produces regional jets, quite a lot of them, very well respected. So they're through this certain qual hurdle. Richard Abulathia and Kevin Michaels at the Aerodynamic Advisory Group have a nice paper sort of questioning, will Embraer enter the single aisle market within the next 10 years? For the KC-390, that was about an 11-year development cycle from, essentially corporate saying, yes, you can go, to having an operational aircraft in service. So if you look at it, see 10, 11 years, Embraer could field a airplane that's competitive with a 737. If you look at what Bombardier tried to do with the C series, they got it done. It broke the company. Embraer is looking at that awfully hard. If you look at the WTO disputes, they tell you a lot. So WTO, Airbus and Boeing are always suing each other in WTO because the proceedings are closed. The next two that were
That's
suing each other,
hilarious.
right, because they can't sue each other in open court because far too much information would come out.
Oh, yeah, yeah.
Um, Too much dirty laundry. It's tough business. The next two were Bombardier and Embraer suing each other as sort of the next level proxies. And Bombardier is just decimated after the C series being sold off and everything else. So Embraer, I think, could. field an aircraft within the next 10-ish years that could, disrupt the duopoly. They're pretty pissed off at Boeing after Boeing backed away from the deal to buy Embraer. Yeah, I know more about that than I should probably, but their anger runs very deep. So I don't know if that's enough to make them go do it, but it can't be discounted that
Mm.
inside to the economics they have. The next level is, 10 plus years. Comac. I mean, Comac has built the 919. They are flying it. They have a market in Asia to sell this airplane. Can they sell it to Bangladesh? Can they sell it to India, Burma? Their sphere of influence, definitely. Can they sell it to Europe and the United States? That's one hell of a question. Because of, if you own your own country, right? As China owns China, we can't tell China what to do inside their country. They want to build an airplane, their own version of the FAA certifies it to fly. Hey, they can fly it. Can they fly that airplane to Europe? Oh no, they have to have the EASA certification. Can they fly to the United States? They've got to get FAA certification. So can they get the airplane certified?
I
There's
wouldn't
a
trust a Chinese plane. I'm sorry, I have to say it wide openly. I would not fly into a Chinese plane. As far as
so
I knew
the,
it being a Chinese plane, I would not go in there.
there's you're probably picking up on some of the cultural nuances of Chinese design and who is responsible for finding fault culturally. It's an interesting question because it places a lot of burden on the acquirer of the airplane or the acquirer of a technology. But I think the Chinese are smart enough to know that they have to get this right. There's a geopolitical component. Do we want to let a Chinese airplane, a commercial one, into our airspaces? What could it carry in addition to people? What surveillance technology could be there from a geopolitical standpoint, from a trade standpoint? I mean, there's all of these geopolitical questions about do we want this to happen? And those are complicated questions, and it again goes to the long-term lifespan of these geopolitical relationships. Could you let a Chinese airplane fly in the U.S. for 5 years, and then new president comes aboard and says, "Nope, we're not going to allow it anymore." Yeah, yeah, we can do that. We're our own country, right? The big issue though is cost, and this goes across the board for all these wonderful new ideas in aviation. So there was a company called Eclipse Aviation here in Denver, Colorado. Um, they had a flying airplane. And there's also Adams Aviation as well. They had a flying airplane. And I may get the stories mixed up because the people cross an awful lot in Colorado.
Okay,
Um,
fair enough.
but they had a flying aircraft with initially Williams, and I think they transitioned to Pratt engine. So they had a certified engine. They had a flying twin engine business aircraft, and they were trying to certify it without prior basis as an airplane manufacturer. They got an extra $500 million, which last time I counted is like half a billion, right? They couldn't get through certain qual. There was a rumor, and I don't know, I'd have to fact check it. So let's call it a rumor that the Chinese were trying to buy the Bombardier C series for the certain qual that it would bring along with it. So how is China going to go through certain qual for a 919 in the US and Europe without prior basis? Almost everything you see certified is from prior basis. Really simple example. You have an aircraft company. You're going to hire me and a few of my friends that worked A320neo nacelle. And we come over, we use the exact same tools, exact same analysis method. You think this is great. I'm going to take this to the FAA. And they said, well, how do you know that these analysis methods are good? Well, all these guys used to work for Boeing or Goodrich or GE. And I said,
Mm-hmm.
yeah, GE has that basis, not these guys. It belongs to GE. So you have to prove that your analysis represents this parts. Um, and that's not easy to do. A case in point, you can look this one up, BR725, built by Spirit, the nacelle. They found out that they needed to go through and do more cert and qual To own the certain qual for this aircraft, it cost them $40 million. So
Wow.
that program, last I checked, it's been some years ago, was it $87 million and a $40 million forward loss roughly. Because they didn't take into account that they were using the certain qual from Boeing material specs on an engine going to Gulfstream, which by
Wow.
Rolls-Royce.
Wow.
Do not underestimate the cost of certain qual. I mean, it is what is going to kill so many startups if they can't find a partner. The other one that I want to bring up, see if my memory works well, Aeron, 14-year development for a supersonic aircraft. Texas billionaire behind it. They were going to build a facility down in Florida. They had partnered with Lockheed for a while, which gave them, good supersonic inlet design. They had an agreement with Boeing that would hopefully get them the certain qual. After 14 years, they ran out of money. Tom Dye, which was their CEO, is now the CEO of Sierra Space. His team's over there. Um, it's hard. So when someone says, "I'm going to go cert something that's new," the cert cost for a 919 is upwards of $1 billion.
Wow.
And that's assuming the US and Europe are even willing to entertain them going in the process.
That's insane. That's
So,
an
but
insane amount
but
of money.
we're flying, I don't know if you're married or what. We're flying grandkids and
Mhm.
grandmas. We're flying the public. These are people who did not sign up for any risk. They signed up to go from point A to point B at essentially zero risk. And that's the implicit promise in air travel. We are going to be so careful in developing these airplanes and making them safe. And that is going to be reflected in the cost to do this.
Yeah. Okay. I mean, if you put it into perspective, it kind of makes sense. But you hear these numbers, and they're insanely big numbers, and you're just wondering, how does someone kick off in this industry?
You don't. I mean, that's the dirty little secret. It's protectionism, strategic competitive advantage, right? That you don't have prior basis. If you want to get prior basis, you essentially have to partner with someone who hasn't, who can say, yes, I can trace my ANSYS simulations back until when I started doing this on the Boeing 707. And I can tell you that I've got the history and I know what I'm doing. And this what we've done for our next airplane. It's what we did for the last one, which builds on everything else. Going from zero, I mean, Blake Scholl and Boom, they're here in Colorado. I always wish them the best of luck, but their hurdle is not building an airplane. Their hurdle is in certifying the airplane.
It doesn't sound particularly fair having a very closed, entrenched market where not a lot of new players can come in. It kind of sounds like it hinders a little bit innovation.
I
Uh,
mean, you have to think about this because it's a great question. Are Boeing and Airbus focused on innovation? No, they're focused on aviation safety above all else. That's why it's hard to innovate because any innovation has to be tested in every direction possible to make sure that it's actually safe. Sometimes, being on the inside, it feels a little bit silly, but you get so many questions from so many people. Um, I'll pick one that was fascinating. Ownership. So ownership is the ability to see where you are on a map. So that blue dot or the gray dot on a Google map of showing you where you are. The Flight Deck Pro has an option for pilots to see ownership with their airplane, so they can see where they are on the runway relative to other airplanes. This was highly controversial and is still not allowed in some countries. You look at this
why?
and say, well, why? Yeah, exactly. Why? Why is knowing where I am a, as an airplane pilot, because I don't have a rear view mirror on most airplanes, that tells me what's happening behind me. My field of vision's limited. The argument was that The pilot is not directing the airplane at the airport. The pilot is following the instructions of air traffic control. If the pilot can look around and see what's happening around him, they may be inclined to make a movement based on what they see, not based on what they're being told by air traffic control. And this would introduce risk into the system. It's a valid
Huh.
argument.
It is a valid argument.
So yeah, for most, in the US and in Europe, ownership is now generally allowed, but it was highly controversial. And this isn't even about a new technology, a new material, that's going to affect the airplane. This is on the ground movement of the airplane. Now, most
Okay.
incidents actually happen on the ground, but they're just economic incidents. Two planes bump each other. It's not fun to repair, but no, generally the damage is pretty low because airplanes, except when landing and taking off, move pretty slow relative to, cars, other such things. So yeah,
This is
it's a complicated world.
it is complicated. There's a lot of protectionism around it, and it sounds very, very complex and hard to maneuver around. It's been a very interesting discussion. We are running a little bit on time, so I want the next couple of minutes to spend them on you. If you had to give one word out to the wise, or to young kids that are looking to get into the aerospace industry, what would you advise them to do?
Oh gosh, it's a tough industry. It's a cyclical industry. I would look at the areas that are not as regulated, such as satellites and rockets, as places where you can really expand the technology. Um, I usually tell people don't do it, go into finance because the math is really hard. If I knew what I do now, I would have just gone into finance and probably, made my millions on Wall Street because you need to have some passion about it. And for someone of my generation, our passion was the Cold War. We were
Huh.
faced with the imminent threat of the Soviet Union. We were looking at it. I worked on the National Aerospace Plane, heat transfer years ago. So we were at the forefront of technology for democracy. And this is what was so cool back then. Now what I see happening is there's this new zone where technology is being developed. I think the space is very viable. I mean, getting technology satellites up there is really good. I would caution them to be careful of the UAV market. We already have helicopters. Richard Abulafia and Kevin Michaels will talk about this a lot more if you Google what they say. But essentially, we have helicopters. If you look at production rates, cost, a personal air vehicle is going to cost at least $500,000. It's going to cost 100,000 dollars a year to maintain. Uh, the market for that, yes, it exists in Las Vegas when you're going to go take one and go see the Grand Canyon. Or if you're a billionaire in Dubai, you're going to hop between buildings. There's a market, but the market is smaller than the market for Ferraris and Lamborghinis because a
Oh
Ferrari and
wow.
Lamborghini cost a quarter as much, right? 250,000, and their annual cost to maintain are about 25,000. So I don't know why my computer's doing this in and out thing, but you have
Okay,
to
don't
look
worry
at
about
it
it.
from a basis of potential business. The space business is, as long as we don't lock ourselves in the country out of space with too many things up there, too much space junk. It's very future looking. Personal air vehicles, it's very niche. Taylor Swift, absolutely, she can have her G650. She can have her $500,000, personal air vehicle. There's no question there that she can
Mm.
do it. But am I going to have one in the garage next to the Audis? I don't think so.
Okay, I think that's the most poetic way we can end this. Thomas, I really appreciate you taking the time and giving us an introduction into this. I think there's so many more things that could stem from this discussion and ways we could go about it. I'm not gonna do that now, but I think a follow-up is due at some point in the future if you're okay with it.
Certainly, it was an enjoyable conversation.
It
Hopefully,
was it
your
was
audience finds it useful and none of
it
my
was
friends get upset.
I hope so too, but we're always happy to host your friends too if they're upset. So we'll call it
All
a
right.
day. All right,
All right,
cool.
thank
Well,
you.
it was great having you. I wish you all the best and thank you for participating in this.
All right, take care.
Ciao, ciao.
Bye.
Bye-bye.